Very good evening to all of you. Welcome to the second session of the workshop series Road to Warzone Enigma 24, conducted by the Mathematical Society of University of Mora. I'm Rahul Leela Ratna and I'll be your moderator for today's session. Altogether, we have planned 6 workshops and 1 industrial session for you. So all of you are eligible to participate for the hackathon, which is also a part of this workshop series. This workshop series is ideal for anyone who is new to Python and also who has the passion to develop your Python programming skills along with the mathematical related concepts. This workshop series will be really helpful for you because the modules will to cover up the content in the first semester in the future. So our team Mora Maths had worked long and hard to provide the best of the materials we can give you and to prepare you to any international hackathon competition or any programming competition. So today we have our esteemed speaker, Sajitha Jaivikrama of the Computer Science Engineering Department of the 21st batch. So he will be covering the Python control structures and the functions. So I must give a kind reminder for any questions during the session. You can of course unmute and ask, or you can put them in the chat. So over to you, Sajitha.
Thank you, Rahul. Good morning, everyone. Sorry, good evening, everyone. Hope I'm audible to you. And I think you can see my screen, right?
Yes, you're audible and we can see your screen.
Okay, so this is the workshop 2 of Python programming. So today we are going to discuss about control structures in programming, like split statements and loops. And then in the later part, we'll be covering functions as well. So I think you already know what the control structure is, right? You know what a control flow is, right? So it's the order in which individual statements of a program are executed, right? So I think you have already learned the sequential control flow in the previous session. So that's how normally a program works. So what happens here is each statement is executed one by one from top to bottom, each statement after the other, right? So today we are going to explore more into some other control structures such as selection and their so here you can see some flowcharts and of sequence and selection control structure. So in sequence, what happens here is, so the first statement executes and then it moves to the second one, right? So that's the normal procedure program would work. So in selection, so there are 2 flows that the program can follow. So there's a decision to make, and if that condition is met, it will follow this block A. Well, it will follow the block B side of the code and come to an end, right? So we will look more into how this is done and things later. So here's the flow chart for repetition and subprogram. So in repetition, as the name suggests, several lines of code. So the body of the loop is repeated over and over several times in the code, right, in your program. So there's the decision again here, and as long as the decision is true, the loop body will continue to program different programs inside the group, and it will be executed. So we'll talk about this later. So that's what happens with functions in programming. So first we'll look at selection control structure. So this is the most fundamental structure, and in selection structure, so if selection is the most basic one, right? So if statement is the simplest decision making statement, we can use it to find whether certain set of statements or a block of code will be executed or not. So in order to do this decision making, we should set a certain conditions, right? So Python supports the usual logical conditions from math, as you can see here. So these are the Python syntaxes for the logical conditions, right? So to check if the two values are equal, you can simply use two equal signs, and other ones are pretty much common like in mathematics. So for less than you use the less than sign, and for greater than you use the greater than sign, and so far. So the one thing special to note here is that for equal, to check the equality, we use two equal marks. If it's not only one equal sign, so if we use only a one equal sign, what happens here is the variable will be assigned with the new value, right? So it will be a equals to b. So to check if they are equal, we use two equal signs. So yeah, so these conditions can be used in several ways, most commonly in if statement and loops. So here is the syntax for the if statement. So it's very simple. So what you have to do is the keyword is if. So if here we write our condition or expression, and we put a colon, and in the next line we keep some indentation here. So that's some white spaces, and we write our statement. So it's pretty easy and simple. So what you have to keep in your mind is this line indentation. So this statement or the block of code inside the if block should be indented from the if expression part, right? So it is possible to use only a single space here. I mean, there's no rule saying that you should keep this much of spaces here. But normally what we do is we use the tab key from the keyboard, and it's about 4 spaces, and yeah. So, and it's much more easier to use the tab key, and it's the general way, right? So if we don't do this, what happens is your code will run into some compiling errors if you don't do the.
Sajid, excuse me, there's a small reminder which I have to tell.
Yeah.
Yeah, there's a link to ask your questions from the Sido app. So all participants, please use that link, and so from that one also you can ask your questions. Okay.
Okay.
Right.
So I was saying that Python relies on this indentation, right? So indentation is this white space at the beginning of the line, right? So Python relies on this indentation to define the scope of the code. So other programs normally use curly brackets here, so it's much easier to use curly brackets, but in Python you have to keep this indentation. So let's try a few codes in the IDLE. So I think IDLE in the last session, and you know how to do this. So I'm trying some codes here. So do some if, right? A and B, and assign some values to them. So what we use is if A is less than B. So A is less than B, colon. And then when we hit the enter key, you can see the indentation is already there, right? So this Python ideally, so Python shell automatically put some indentation there, so you wouldn't forget it unless you just erase it, right? So you can write some statements here. So let's say in A and B, and you hit enter. You can see that it prints that A is less than B, right? So it's pretty much basic, right? So if this condition is met, the code will print, the code will execute inside the if statement, right? So now the problem is, what if we need to do something if A is not less than B, right? So let's say that A is equal to some value like 50, and so now also in ideally, I guess you already know, you can just come here in using the cursor and hit enter to copy paste the codes directly, right? So if we check this, you can see there's no output, right? So A is 50 and B is 34. So it's this condition is definitely false, right? So 50 is not less than 34. So this code, this line will not be executed. And since there's nothing else to do, like the program is all that, it will stop executing. Now, if we need to do something, even if the condition is false, we use else block, right? So here we have if else selection structure. So here, along with the if statement, else keyword can be used. It's optional, of course, and it provides an alternate block of statement to be executed in the Boolean if the Boolean expression is not true. So that means if the Boolean expression is false, this part of the code will be executed. So let me show you. So here, so now we know A is 50 and B is 34. If I just paste this part and say else and print so here what will happen is now the compiler or the computer will check for this condition: is A less than B or not. So A is 50 and B is 34, so it will be false, and the program will not execute this part, but it will jump over to here. So it's an else code. So this part will be executed because this was false. This condition was false. So it will print A is not less than B, right? So here, just something that came to my mind. So I could have written that A is greater than B here, but that's not the case here, right? So we have checked only if A is less than B. Now A might be equal to B. Now if A is equals to B, if we say that A is greater than B, that's also wrong, right? So, I mean, that's not something. That's something that you should change, right? If A is not less than B. So in the slide, so here is the formal syntax for if-else code, if-else block. So what happens is if expression is true, this use statements 1, 2, and 3 will be executed. And if the expression is false, this part will be skipped and it will jump over here, and statement 4, 5, 6 will be executed. And this statement 7 will be executed no matter what the expression is, right? So it's outside of the if-else part. So it is very clear with this indentation, right? So this is the if block, this is the else part, and this is outside of those parts, right? So yeah. So I just quickly show you something. What happens if you forgot to keep these indentations, right? So if I just, let's say that I forgot to keep the indentation here and try something like this. So if I hit enter, you can see there's a syntax error and it says expected an intended block after if, right? So there must be an intended block after this if syntax and also after this else part. Like you can't do either this one. You can't keep else inside the if part, right? Else should be out of this. So you should always remember those things, right? So next we have elif. So elif is a keyword in Python that stands for else if, right? So what happens is, like, it's the Python's way of saying that if the previous condition is false, try this new condition, right? So you can have multiple conditions inside the same if block with using this elif. So elif statement allows you to check multiple expressions for true and execute a block of code as soon as one of the conditions evaluate to true. So that's very important. This will execute the block of code as soon as one of the conditions is true. So this the order we use with the conditions and elif is very important, right? Because once the condition is met and the block of code is executed, it doesn't check for the next if block if into the end. So here in syntax you can say if expression 1 is true, this part will be executed, only this statement. And if this expression is false, it will check for this condition. And here if this is true, so let's say this expression 2 turns out to be true, and this statement, this part will be executed, and it would not even look at this it should rest of the code, rest of the if block. It will jump out of the if block as soon as that part is executed. So even if the expression 3 is true, it doesn't matter, because as this says, execute the block of code as soon as one of the conditions evaluates to be true, right? So even if the expression 3 is true, the expression 2 is already true, so it will jump out of the code, right? So let me show you this in ideal way. So here, so I have A and B here. So I'll use the same code but with the elif part, right? So here I can add elif is equal to B in B. So yeah, it says A is not less than B, because now the values are A is 50 and B is 34. So this condition is false. 50 is not less than B. This condition is also false. So this is the part which will be executed. Now if we set A to be 34 and try this part again, it says A is equal to B, right? So this condition is false, this wouldn't be executed, but this condition is false, so this line will be executed, and it doesn't matter what is here. Okay. So about the order of the condition, so let's say we have something like this: A is equal to B. A is not equal to B, and A is greater than B. So A is 64 and B is 34 here. So A is definitely greater than B. So both these conditions are correct, right? But what happens here is it only prints out this part. So yeah, this is wrong because I say here A is less than B, but it should be not equal to B, right? But you can see that only this block is executed. It doesn't even bother to check for this condition, right? If it checks it, it will turn out to be true, but it doesn't matter because there's already a condition met and they have already executed the block. So next we have nested selection structure. So this is basically if blocks, so if else blocks inside other if else blocks, right? So as the name suggests, it's nested inside one. These are pretty useful when we want to check some condition once after the condition is already met, right? So something like let's say when we are checking for when we are coding a login system, so first we check the user, and if the username is correct, then we check if the password is correct or not, right? So that's the first condition. That's our first condition. Let's say in this is if the username is correct. If the username is correct, we will print out that your username is correct, and we will check again inside this if else block. So it's the if block here. So we will check for if the password is correct or not, and if it is correct, we can say you are clear to login. Else, we can say the password is wrong, right? So yes, we can use multiple LEs, even multiple LEs inside this nested loops. So we will take a look at some examples here again. So I'll try some different examples here. So let's say we have a number is 24, right? So I can say something like if it is greater than 10, print x is greater than 10. And I'm going to check if x is all greater than 20. So if it's greater than 20, yes, else let's say print between 10 and 20. Wait, so x is 24 here. So it will check if x is 10 and it's true. So it will print x is greater than 10 right here. And then again it will check if the x is greater than 20. And yes, x is greater than 20. So this part will be yes. So if I change it to something in between 10 and 20, you can see that it says x is in between 10 and 20, right? So so something new is, so in these conditions we use in this conditions that we use, we can check for multiple conditions in the same line, right? We can use logical operators. So I think you already know what logical operators are, like AND, gate, or, and not, and XOR, and things like that. So we can use them inside these conditions in the if blocks to check for multiple conditions at the same time. So instead of doing this, I can just simply say if x is greater than 10 and x is greater than 20. So it's not very useful to check if x is 10 and 20, right? I mean, if x is greater than 20, then already x is greater than 10, right? So let's say if x is less than 20, we can check if the number is in between 10 and 20, right? So say in this. So so like this you can add. So this is a condition, one condition, this is another condition, and those conditions are connected using a logical operator. So you can add multiple conditions like this. There need to be two conditions, so you can add any long here, and as long as your code is stays simple and easy to read and is efficient, of course, you can add any much conditions here in the same if code is else code, or you can use nested if like this as well. Right, so that's what you have, what you need about if so selection control structures, right? So it's pretty basic, like just like in English, right? So if some condition is true, then this part will be executed, else the other part will be executed. It's pretty basic. So next we have loop control structure. So loop is something something important in programming. So what is a loop? So in programming, some codes needs to be repeated a number of times again and again, right? So for example, think about finding the factorial of a number. So the normal mathematical way is, if we need to find the factorial of 5, so we will be multiplying 5 by 4 by 3 by 2 and so forth until 1, right? So if we need to find the factorial of some, let's say x, so it's a variable. So what you do is you keep multiplying x by x minus 1 by x minus 2 until you meet 1, right? So if we look at this in a programming mind, so what happens here is just a 2 or 3 lines of code, same code is repeated again and again, right? So instead of writing this same code repeatedly, we can use loop. So in Python, we have two loop control structures. One is for loops, and the other one is while loop. So we are going to look at this in detail. So for loops are used to iterate over sequences, like list, tuples, or strings. Right? So here's the syntax. You can see it's simple. So for here we have a variable, so it's called iterating variable in sequence. So this is the sequence, like here, so a list or a string or something, and then after a colon we have the statement, so the block of codes to run. So here you can see, so this is the code and this is the output. So if I try this in the VLU, so for, let's say, C in, so I use C because it's like character, right? So for each character in this string, so this ABCD is the string. For each character in this string, print that character. So it will iterate over this string. So A is there, then B is there, C is there, and D is right. So also you can use for loops to iterate over list. So if I have a list, let's say my list is equal to some path like that. So you can use for loops to iterate over string. So for I in my list. Okay. So here this I is something some variable, right? So you can use any name here. It will loop over each object in this list. So in Python, this string is also a list of characters. That's why we can use for loops like this directly, because it's a list of characters. So each character in a list like this, right? So you can see that in this example, the for loop does not require an indexing variable to be set beforehand, right? So we can just go to a stream without an index. Like we don't say that the first one in the my list, second one in the my list. We just the I is directly this object, not the index of this object, right? So if we need to uh, loop some objects or some code some few times, say some known time, so let's say 5 times, right? We need some indexing, right? So to do this, we can use the range function. So here range function. So a range function is used to loop through a set of code specified number of times, right? So range function is a default function from Python. It's built by those who built the Python, right? So it will return some numbers from starting. So the syntax is like this: range. There's a starting index and a ending index. So it will return the number from m to n. Right? So this will exclude n bar, right? So you have to remember that range function returns numbers from m to n without n, right? So here you can see that we use for number in range 1 to 5 print number, right? So there's no 5 here. There's 1, 2, 3, 4. There's no 5 here. So the range function returns numbers from 1 to 5 without 5. So the last digit is always excluded. And yeah, so we can try this in the code ideally. So I in range 1 to 5. So there's a syntax error saying that I missed the colon, right? So I forgot to put the colon down here. So don't do that. Print I. So you can see there's no 5, right? So also there are few things more about this range function. So we can use something like this range 5, right? So the starting number in the range function is by default 0. If we don't give a starting point, it will take this 5 as the end point, and it will return numbers from 0 to 5, and yes, without 5, right? Because the last number is always excluded. So here you can see this is equal to this, right? So you can use this in loop. I'm going to copy this and so here you can see there's 0 there. So by default the starting number is 0, and it has all the numbers up to 5 without 5. And by default, the step size, so the incrementing size is 1. So that means you can see that each number is 1 greater than the previous one, right? So it always increments by 1. We can change that as well. So all you have to do is just add the step size. So let's say from 1 to 30. We can add the step size here as another argument. So 3 means 3. So if the first number is 1, then the next number will be 1 plus 3. So it will be 4, right? So you can see here, you have from 1 to up until 30. So it's something you should remember, like you will get used to it using the range function. And yeah, so and another thing, so we don't usually do this because we don't usually do this, right? So but we can we can't the for loop cannot be empty. I mean, you can't just say something like if I in range 5 and expect that to be run, right? So I keep entering and it doesn't even go to next line, right? So there's so if you run this one, it will be give you an error. So if you need to, for some reason, if you need to keep an for loop empty, I don't know, maybe for debugging purposes, you can simply do is what you can do is so for in range 5, you can simply say pass. So pass is a keyword in Python. You can sit to simply say that there's nothing, just move, right? So that way it won't give an error, it doesn't give any output as well. It's basically saying that this part is empty, you don't need to look at this. So that's something you can remember, right? And then next we have while loops. So while loop executes a set of statements as long as the condition is true, right? So this is useful when we don't know how much time the code needs to be looped over. We run 5 times, right? So that's why we use range 5. Now here in while loop, we don't know how many times it runs. So for example, if we are checking for a password, now for password, of course there's a limit, so you can't enter the password like more than 3 or 4 times. But let's say you are checking, you are getting an input until the user enters the correct password, right? So we don't know how much long it will take for him to enter the correct password, right? We don't know how much wrong password he would use. Now, for something like that, we can use a while expression, while loop. So here, while you can set the condition here. So in our example, it would be like something like while the password is incorrect, ask for the password here statement, right? So it will loop through this part, and here you can check for the password if it's correct or not. And if it's correct, this expression will be false, and it will jump out of the loop, right? So here we have an example that gives the same output as the previous in the previous coding from the for loop. So output is from 1 to 4. Here what you can see is down in for loops we didn't use these initializing variables and those implementing, they were already there, right? So all we have to do is like use for I in this range, so it will be 5 here, print I. Now in while loops we have to do this by ourselves. We can set some initializing variable. So here the count is set to be 1. Then we have the condition until count is less than 5, we print 5. And also we have to do the incrementing by ourselves, right? So if we forget to do this incrementing, what happens is loop will continue forever, and yeah, it will give really bad errors, right? So it will be a never-ending loop and keeps repeating doing the same. So we will try this. Here in, so let's say, so in this slide it should be count here, right? It's a mistake. So let's say count is equal to 1, and while count is less than 5, then count and count is incremented, right? So it's normal. So now let's see what happens if we forget to do this increment, right? So yeah, so this gives nothing. So because count is already 5, right? So this condition is false. So because you can see count is already 5. So let's set count back to 1 and try this. So you can see it never ends and it keeps running until I stop it. So you can see there's lots of ones, right? So the count does not increment, and as a result, the loop never ends, right? Loop keeps running again and again. So that could lead to many problems. So one more thing, we can use nested loops just like in the if statement. How we use nested if, we can use nested loops, right? So here the inner loop will be executed one time for each iteration of the outer loop. So before moving forward, I'm going to show you how to I'm going to show you how to create a Python file. I think you maybe already know this, but so in this, ideally you can go to here in file. There's the option called new file, right? So if you click that, you get a new text editor. You can type Python here. So right, you can get the suggestions as well. So to do that, of course, if you have enough characters already typed, you can simply press Ctrl plus space, and it will pop up some drop down menu like this. You can select the keyword to it, right? So let's say, and after your Python code is done, you have to save it. So you can save it using Control S over here. Let's say desktop. So make sure to get this extension as .py, so that's the extension of a Python file, right? And you can run this with this run module or F5, and it will run on this shape, right? So just keep in mind how to do that, and you can do so. Let's try a nested loop here. So yeah, so I'll have two lists. So list one will be and list two will be some numbers, right? So just to make it much easier. So in selection structure, what we do for nested if is we type the if condition, and next line we try another if condition, right? So it's similar in here. So what we do is for I in list one, we can add another loop inside this loop for j in list two, right? So let's say print I comma j. So what happens is, so for each iteration in this list one, this loop will be executed, and that means for each iteration in this list 2, ij will be printed, right? So let's try this. Run. So you have to save it and run. You can see here for letting the list one, the inner loop is executed. So the numbers from list 2 is so a1 a2, and then this is the second iteration of the outer loop. And yeah, so you can use this in various scenarios, like when you are working, if you have to work with matrices and 2 by 2 arrays, this will be pretty useful. So nested loops, right? So yeah, so keep that in mind. So we'll continue our session. So we have break and continue. Okay? So these are two special commands in Python, as well as many other languages. We have break and continue. So break terminates the loop execution, and the program continues with the next statement after the loop, right? So as you can see in the example, the loop will print count. So here again it should be count. As long as so count goes up until 6, loop will keep printing count. As you can see, here's the output 1, 2, and 3. So once when the output is 3, sorry, count is 3. So here we have an if block. So checking if the count is equal to 3 or not. So if count is 3, it says break, right? So after that, you can see the program haven't executed. So if we try this here, so here's this tool, Python tutor. I don't know, you can see the link. You can just Google Python tutor, and this is very useful to visualize codes. So you can, it's not just Python, you have some other languages as well here. Java is there, C++. Yeah, it will be quite useful in the future. Right? So if I try the same code here, so we have count is equal to 1, while count is less than 6, print count if count is equal to 3 big, and count should be incremented. So remember to do the incrementing, right? So it's the same code that's here. So if I click this visualize execution, you can see how this program executes in a computer. So this is the output field, and here you will have variables, and this is the program. And so the red arrow indicates the next line about to be executed, and there's this green arrow that says the line that just executes. So if you click next, so here you can see a variable is made as count, and its value is 1, right? So while count is less than 6, it will keep printing the value of count. So you can see the count is printed and checks for the condition in the if it is false. So it skips the next line. I mean, it skips the 5th line, goes to line 6. Count is incremented here. You can see, and it keeps doing this until count is equal to 3. Right now, the count is 3. It prints the value, and once the code comes to the if block, you can see that the condition is true, and it goes inside, right? So it says break, so it will end the loop and jump out of the code. So because there's nothing outside of the code, it will stop the program as well. But if I have something here outside the loop, say print the end. And I do this. So you can see so here the break line is executed, and after that the code jumps over to here, right, outside of the loop, and it prints the end, and the program will end. So break keyword is pretty useful for condition checking inside the loop, right? So like this, you can check for some condition and stop checking, stop the loop. Like in the previous case, like when we check password, so here it may be like while password is not true, take an input as password, check if it is correct or not. If it is correct, you can break the loop, right? So that's really useful. And next we have continue. So continue keyword is used within loops to skip the rest of the code inside the loop and process to the next iteration. So this is very important. So continue is used to skip the rest of the code inside the loop. Okay? So here you can see that printing is after the checking for the I to be 3 or not, and you can see the the number 3 is not printed in the output, right? So what happens here is, so I will go from 0 to 5, right? Remember the last digit is not there in the range function, and while I is not true, so it's not 3, so it will print I, right? So it checks if I is 3, no, and if I is 3, it says continue, so it will not print or run any lines after this. It will just skip that iteration and jump into the next iteration. It doesn't jump out of the loop. It stays inside the loop, just jump into the next iteration, right? So in this visualization tool, let's go for in range 6. So I'll just add some lines here before the if I is equal to 3, and let's say and print something else. So let's say so I just added these lines to make it clear to you guys how this works, right? So here when we run this, you have the I variable here. It starts with 0 because the default starting value is 0, and it prints this line, and it checks if I is 3. Sorry. So it checks if I is equal to 3 or not, and it prints the I and the rest of the code, and it keeps looping until I is equal to 3, right? So now I is equal to 3. Now the if condition inside the if is correct, so this block of code will be executed here, and you can see the continue is for the anything before the continue keyword will be executed. So this line, even this line is executed. So you can see here that line is executed, and then after the continue keyword, the program jumps into the next iteration of the loop, right? These codes will not be anything after the continue keyword will not be executed. So it just jumps into the next iteration, and it keeps going without a problem, right? So the difference between break and continue is break stops the whole loop and jumps outside of the loop, while continue stops only the that iteration, right? So it just jumps into the next iteration. So you'll have users with this in the future. You'll get to use them. So and next we have functions, right? The function block of code which only runs when it is called. So as you can, so here's the function code. This block of code will only be executed once the function is called, right? So you can pass data and parameters into this function. We look at that, and it is organized and reusable. Like we can use this same set of block of code in somewhere else, right? We only thing we have to do is just call that function by its name, right? And most commonly, we write functions in a way that they perform a special single specific task. So possible like do multiple things inside the function, but so normally the standard method is we use a function only to do a special single task, right? And now the question is why we should use functions, right? So yeah, they allow the same piece of code to run multiple times. That's a major use of the function, right? So you don't need to repeat the same set of code again here when we use functions, because functions like have to do is change only one, and it doesn't bother. Also, they break down large programs into smaller ones. They make problems much easier, more organized and manageable. And functions can be shared and used in other programs as well. Like so, two numbers in my some program named calculator, I can use the same function in some other program as well to add two numbers, right? So they can be shared. And the other thing is, so we can use function to encapsulate things, right? So let's say that I am a developer and I have some other one in my team. We both develop the same program. So I have some code, some function that adds up few numbers and returns the result. And the other guy, he doesn't need to worry about how I do this. He doesn't need to know about how I add things. He just calls the name of the function and it will return the value that uh, those numbers added, right? So that's another use of function, right? So here's the syntax of a function. So yeah, function begins with the def keyword, right? So a function is defined using the def keyword. Easier to remember, right? Define a function, def function, and then after a space we have the function name. So this can be anything you want. So make sure to use something meaningful there, so, because some others might be reading your program, reading your code, so they need to be, the function names need to be meaningful, right? And then inside this parentheses we add the parameters. So these are the values or variables that are passed into the body of the function, and there can be any number of parameters. You just have to simply separate them with comma. And after a colon, we have the body of the function, and it is indented for Python. So first, so normally what we do is just after definition of the function, we add this. This is called a doc string of a function. It's a special type of comment. I guess you already know about comments. So we use comments to explain our code to someone else, like some other developer. So this doc string is there for that. So in the doc string, we what we have is, so we say that this is the function that will do this task, and it takes these parameters or arguments, and it will return these values. So it's optional, it's not a mandatory thing to add, but I recommend you to use doc strings as much as possible, because that way it is easier for you to, I mean, it will be helpful for you to understand the code and also someone else that is looking your code, right? So and then we have the body of the function, and here we have the return expression, right? So this is the part, this expression will be returned to the main program where the function is called. And this is also optional. You can just leave return only without anything, without any expression here, or you can just not add a return at all, right? So by default, any function will return none, meaning there's nothing to return, right? So you can see return none is there. So let's try to write some functions, right? So in ideally, you can just say if my function parentheses colon, and then in the intended block, write your body function. So as you can see, nothing's happened, right? Because yes, the function is defined correctly, but we haven't called that function. So we need to call a function. That's why functions are there, right? We need to call them. So once we call the function, you can just type my function here and add the parentheses. So if there are any parameters here in the definition, you have to add those arguments over here, and just hit enter, and you can see that function is called and it is executed, and you have this is my function here, right? This output. So if we need to, so let's see a few example, another example with the parameter, right? So I'm going to define this function again. So I'm going to add name here. So this is a variable. Variable name is name, and I can use this variable inside the function body anywhere you want, right? So I'm going to print the name as well. Name is name. So now if I try to call this function, so if I do this, if I call the function like it gives this, I have one argument missing, right? So there's a parameter here. So I have to add those parameters or values for these variables when I'm calling this function. So I have to add something here as the name, right? So you can see now the function body is executed, and we'll be looking at arguments again and these parameters and all. So function arguments. So arguments are used to pass information into the function, right? Inside the function. So here are the parameters. So these two words, parameters and functions. So they are not very different, right? So parameters is the variable that are listed inside the parentheses when defining the function. Now here is the function definition. So these variables are known as parameters. And when I call this function at 3 numbers, I have to pass some values over there. So those values will be the arguments, right? So here, so in this function, you can see here's the definition and this name part. So this is a parameter. So it's just how you say, right? So doesn't matter, but the parameter is name and the argument is John. So the value is the argument and the variable name is the parameters. So yeah, and you can add as many arguments or parameters when you define some function. And there are four different types of arguments. So there are required arguments, keyword arguments, default arguments, and variable length arguments. So we'll be looking at them. So required arguments are passed to a function in the correct positional order, right? So now, and the number of arguments in the function call should exactly match the number of functions in the number of parameters in the function definition. So if there are 2 parameters in the function definition, you should pass them in that order, in the correct order when you are calling, right? Sorry. So over here in my text editor, I'm going to define a new function. Let's say my function, and I'm going to add 2 parameters here, right? So name and age. I'm going to print name is name, age is age, right? So now when I'm calling this my function, you have to add the name, right? So let's say John, and he is 23, and I save this file and run this. You can say, so you can see there's no problem. The name is John and age is 23, right? So if I remove one of these, so this is an example for required arguments, right? So these 2 arguments, these 2 parameters are required. If I can't do this, this will generate an error. If I run this, it says there's one missing required argument, right? Missing one required positional argument, age. It says the missing argument is now. And the other thing is, if I have to pass those arguments in the correct positional order. If I switch them, what happens is it will take the name as 23 and age as John, right? So when using these required argument, you should always keep in mind about the order you are going to use them, right? Order you are define them in the code. So to overcome this, we have keyword argument. So this keyword argument, the caller identifies the argument by the parameter name. So this allows us to place arguments in different orders, right? So yeah, it's nothing new. It's just all you have to do is, as you can see here, when calling the function, you should give the what parameter is what and what as it, right? So in this in my code, I can simply say now here age is 23, age equals 20, and name equals John. So now this is the use of keyword arguments. So I have the keyword age and the value, right? So it's not in the correct order as they are defined, but this will not give any error. It runs just fine. Says name is John and age is 23, right? So it's just pretty common, right? So you understand what happens there. And next we have default argument. So here what happens is we set a default value for the parameter when the function is defined. So this is done with simply using a equal sign like this. So this is the default value. So if the user doesn't pass any value for that argument or the parameter, it will use this default value as its value. So you can see there's no error. With we can use only the name, and also we can use name and experience here as well. So we'll try this in the code. So we can set a default age for the person. Say their default age is 20, right? So now I don't need this part. I can say simply like this. And if I run this, you can say you can see that the user or the caller of the function haven't used any value for the age, so it uses the default value. And also I can just pass any other number here and it will work as well. So all this just is it provides a default value if the value is not given. But you have to remember all these parameters with default values should be at the end of the parameters line, right? So like you can't say age is 20 by default and after that take a name like this. So this is not correct. This would raise an error. It's a compile error. Non-default arguments follow default arguments, right? So these non-default arguments can't follow default arguments. They should always define first, right? So keep that in your mind. And for the variable length argument, so if we don't know how many arguments are there, we can add an asterisk mark, right? Asterisk mark is the star, and this is called the arbitrary attribute. Sorry, arbitrary argument. This way, the function will receive a tuple or let's say a list of arguments and can access items accordingly from inside the function. So I can simply say something like so name can be an arbitrary, and I'm going to remove this part and pass the other names as well. Maybe so, right? So I can say first name is, so this name here with this asterisk mark, it's an tuple. So you can take each value with using an index. So 0th index or the first value of the name will be the first argument here. So it will be John. You can at the last name as well, it will be 0, 1, 2, right? And if I run this, yeah, so you can see first name is John, second name is last name is Doe, and you can add many here as well. So it doesn't matter how much you add here. You can always access them from inside the function. So this is the way we use variable length argument, right? So and also you can do this by using a list as well, right? So all you have to do is say that this name is the list, and when passing the function, you can pass a list over here, right? So say my list is something like this, and you can pass in that list. And this is an alternate way to use the variable in functions, right? So run the module and it works as just as fine, right? All right. So next we have return statement. So if we need to return something from inside function to our code, this return statement, right? So for them use the return statement. So return statement exists a function the for this expression to the code, right? So function is code, right? So yeah, optionally passing back an expression to the code. Yeah, it's optional. Return statement with no arguments is same as the return none, right? So and you can also pass some function which will find the addition and the difference of some two numbers, and you need to return both of them to the main code. You can return a tuple with those with both of those values, right? So you know how to use tuples, right? Inside parentheses. So here we have a code. So what it does is, so you can see here that we have used doc strings. So add both the parameters and return them. That's what this function does. It has two arguments. It takes them and it adds them up, and it will return, right? So let's say this in code as well. So I'll use this one. So define one function has two arguments, n1 and n2, and total is equal to 1 plus n2. Print type function. Total is total, right? And we have return total. So to show you, I'll add something here as well after the return statement. It wouldn't be executed, right? So if I add something like yeah, right. So now I'm going to, I have a variable named total. Let's say new total, total 2 is equal to sum of 3 and 4, right? And I'm going to print this again outside the function. Total is total 2, right? So if I visualize this or run this, and you can see here the function is a separate object. You will learn what objects are in next lesson. So it takes these inputs, so the variables n1 and n2, 3 and 4, and it adds them. The total will be 7, and it prints inside this function the total is 7, right? And after that it returns, right? Here you say return value is 7, and this line is not even considered, right? The red line just jumps into here, right? So the total 2 value is 7. It's from this return value. Total 2 is 7, and you can see it prints out here, right? And also we can use multiple return statements as well, like here. So this is helpful with selection control structure. So this code, what this code does is it takes a value and checks if the value is equal to true. If that is true, it will return true, else it will return false. So this return true part is executed only if the value is equal to 100. Otherwise, it will this return false is executed. So you can see here. So yeah, and next we have global and local variables. So this is a part from the functions, right? So you already know what variables are, right? Variables is like some labeled box where you can store some information. So in Python we have two types of variables. And they are global variables and local variables. So global variables are defined outside of a function. They are accessible throughout the entire program, right? And they can be modified from any part of your code, right? Outside of function. And local variables are defined inside function. So they are inside the function, they are defined inside the function and used inside, and they are accessible only within that function, right? And there's no direct way to modify them from outside. So here we have an example. So here this total is equal to 0. So this total is a global variable because it's outside of a function, right? It is common to the whole code. It is common to the whole program. You can change it anywhere. And here we have a function and we have a variable named total inside this function as well. So this is the local variable. And so if we run this, let's quickly run this. It's quite similar to this code. I'm going to I have a variable in total. Let's see what this is the inside the function total will be this. We don't need this part here. And if we remove this part and outside the function total is right. So here what we do is, so inside the function we print the total variable. So here this total variable is the local one, right? And it is written, but there's no one to catch it. So it will be just thrown away. And outside of the function, this total is the global one, right? This one right here. This is global. And this is global. So I think you can assume what will happen here. So if we run this, you can see the inside the function, value of the total is 7. But outside of the function, the total is 0, right? So yeah, I'll just quickly show this in the visualization. So as you can see, there are two variables, right? So in the global variable name total and we see, and inside the function, inside this object, there's another variable total. So the same name, but different variable, and its value is. So we don't, we haven't really catch that value when the function returns it. So therefore, the total outside of the function, the global variable is 0. It doesn't change, right? Because here, if we do something like total is equal to sum, so Now the both values should be 7, right? As you can see, because at here the value is put inside this variable as well. Now, if we need to change this global variable from inside of the function, we have the global keyword, right? In Python, we use the global keyword. It's a function to indicate that a variable being assigned is a global variable, and that variable will be modified inside that function as well. So here you can see the total is global, right? So declare the total as a global variable, and so only change here we have to do is just say this is this. We say that there's a global variable named total, and that total is in 1 plus n, right? We don't need this part here. And now this is not local, this is global, because we have defined the total variable to be a global variable, and there is a global variable named total. So this is this one right here, right? So there's no local variable in this. If I run this, you can see till both values are 7 because there's no local variable here. Both are global variable. So this is pretty useful when we need to values, right? So when we change some value that is used all over the program from a function, from inside a function. So we can try this, right? So we have some more time. So there's another special thing that comes with functions. That's recursion, right? So in programming, recursion is something quite similar to iteration, but it's there's a whole lot differences, right? So recursion is a technique where a function calls itself to solve a smaller instance of a problem. So it's like breaking down a big problem into smaller or more manageable pieces, right? So it's a function that calls that same function from inside that same function, right? So there are 3 basic concepts in recursion. So there's base case, and then there's divide and conquer, and then we have the function calling itself, right? So these are the 3 basic parts. So every recursive function has a base case, right? So base case is the simplest scenario, or where the function doesn't call itself. So it prevents the function from calling indefinitely, right? So like in the while loop, we have the incrementing line. So it prevents the from a lower again and again indefinitely. And in functions in recursion, we have the base case, which is the simplest scenario, then that will prevent the code from repeating itself again and again. And then recursive functions break down a problem into smaller subproblems, solve each subproblem, and then combine them all together and solve the main original problem. So this is known as divide and conquer. So we have the main problem, we divide it into smaller parts, we solve each part, and then we combine them into one major solution. And defining characteristic of a recursion is the function calling itself. So that creates a chain of functions, right? So if I move into the Python tutor here to show you an example, let's say we are looking for a function that finds the factorial of a number, right? So say the factorial, and we take a number as the parameter, so n. So we are going to find the factorial of the n. So what happens here is, so the factorial is as I said earlier, it always multiplies n by n minus 1 and n minus 1, factorial of the n1. And so n factorial is equal to n times n minus 1 factorial, and this keeps doing again and again, right? So n minus 1 factorial is that time n minus 2 factorial, and that's where recursion comes in. So we have a base case. So the base case is if n is equal to 1 or 0. So we know that if n is equal to 0 or 1, the factorial of 0 as well as factorial of 1 is 1, right? So n is equal to 1, return 1. Else, so if the base case fails, so here's the recursive part, say recursive case. So what we do is we are going to take the number n, and we are going to multiply it by the factorial of n minus 1. Sorry. And we are going to return this value, or we can just assign this into something and return it. I mean, we can do something like a is equal to this and return a. So it's pretty basic, right? So you can just cut this part here and paste it over here. So what happens is, we are going to return n times factorial of n minus 1. Here happens is, we are going to call this same function again, right? So inside the function we are going to call that function, and this is just that. So let's say we have a result is equal to factorial of 5. We are going to print it. Right, so let's say factorial of 5 result, right? So this should work. So here we have the code. So if I click next, there's the factorial function is defined, and its result is equal to factorial 5, right? So the n is 5 here. So this is the factorial function, right? Just imagine this is a part of your RAM inside your computer, and so it has n as 5. So it checks if n is equal to 0 or 1. No. So it jumps into the else case and returns n times factorial n minus 1. So what happens here is another instance of the factorial is created, right? So this function hasn't finished executing, but inside it we have the same function once again called, and this keeps going on until n is equal to 0 or 1, right? So we have function factorial function where n is equal to 5, and inside that we have called this function, and inside that we have this, and inside it we have this, inside it we have this, and here n is equal to 1. So our base case is condition is met, and we return value 1, right? So here return value will be 1, and here we have it. So n is 2 times the return value. So the last time return value is 1, so 2 times 1. So the new return value is 2 times 1, right? And it jumps back to this. You can see the code doesn't change, right? So here the arrow doesn't change. So it's returning again and again. So here we have 3 times 2, it's 6, and we have 4 times 6, here 24, and it's returned here. So 5 times 24, we have 120, and it is returned to this line right here. So result will be 120, and it will be printed, right? So recursion is useful for solving problems that can be broken down into simple and similar sub problems, right? So here it's similar, right? Always it's n times factorial of the n minus 1. So that's the key point you have to find. So but you have to keep in mind that recursive functions may consume more memory, right? So as you can see, if this was the RAM, it creates lots of functions. If I use something like some higher value here, say 15, and it may not even work here, right? So yeah, it works, but you can see, so it keeps running down. So there are 53 steps, right? So it consumes memory. So for each this function, there's an object created, part of memory is dedicated or allocated, and it consumes a lot of memory. And with that, because of that, depending on that, it may consume time as well. So, and also there's a limit how deep this can go, right? So Python by default stops going too much deep, and this will prevent from going into recursive loops indefinitely, right? And in some cases, iterative solutions, so using loops is much more efficient than recursion. So that's it for today's lecture. So I hope you learned something new. So we looked at some control structures, if and for loops and things like that, and then we looked at functions and how recursion works. And so you can learn more about these things, especially about functions and this recursion concept so through internet, right? So there are lots of resourceful websites and videos. So keep learning. And I have an announcement to make. So a supplementary documentation will be provided for you for additional reading, and also so there will be some hacker rank problems from this week as well. So you can complete them within this week. And I think the next workshop will be on data structures, and you can join with that as well. So that's it from me. So if you have any questions, feel free to ask.
So hello, everyone. Now we thank our esteemed speaker, Sajitha Jayavikrama from the Computer Science Engineering Department of the 21st batch. And also we thank our organizer committee for making this workshop, for dedicating their time and making this workshop successful to you. So at last, I must remind you that so if you have any questions, you can use the link provided and send it, and then we can send the answers for that to you. So now this is the end of our the workshop 2 of our workshop series Road to Warzone. So if you have any questions, even now you can either unmute the micro mic and ask, or put in the chat. Yeah, so I think now you can leave the meeting if you want. This is the end. So thank you very much to everyone for being with us. So let's join for the next session. And also we'll inform you about our the next quiz in the hacker rank.